All right, so in this exam, I'm going to be giving you a number of multiple choice, and not multiple choice, sorry, a number of short answer questions. This is one of those units that really there's a lot of qualitative, meaning non-numerical ideas that we really need to get down. A lot of conceptual physics at play, and so I want to make sure that I'm really reviewing that thoroughly with you. And hence, this practice exam might run a little bit longer than you're used to, and that's simply because I want you to be well prepared for the real exam tomorrow. So we start with a definition of internal energy, and let's keep it very simple. So it's the total energy of all the atoms and molecules in an object. Now, of course, when we had the notion of internal energy to start with, we didn't have a notion of atoms and molecules. What we ended up having to do was simply use sort of an intuitive idea that somehow energy could be stored in objects. We weren't exactly sure where it was. It wasn't quite a potential energy like an elastic energy. We just had this idea that somehow there was a connection between internal energy and other what I'll call thermal phenomena that we're going to get to in a second. So there are two things that temperature tells us. One thing that temperature tells us is it is a measure um, of the internal energy per molecule of a system. And I say a measure because there are other factors that come into play. I'm writing it down now. The story gets a little bit complicated when we start getting into systems outside of what you might encounter in a beginning physics class or a beginning chemistry class. So when you decide to move beyond the realm of ideal gases into complicated materials with internal structure, it gets a bit complicated, but for our purposes, we'll go with this for now, with the caveat that, if you stay in this business, you will have to modify that definition. Now, the more important thing for us in physics that temperature actually tells us is temperature is a measure of thermal equilibrium. And what this means is two objects at the same temperature don't exchange heat. And there's a lot that we can do to unpack that sentence. Like, what do we mean by exchanging heat, and what's actually happening with the atoms and molecules? And don't they kind of bump into each other and trade a little bit of energy? And what is that about? And blah, blah, blah. And I'll tell you, there is an entire class devoted to studying exactly those questions. And if you decide that you want to be a chemistry major or a physics major, and even some people in biochemistry and biology, you will get to take a wonderful class called physical chemistry, or if you are a physicist, it will be called statistical thermodynamics, where they address all these wonderful questions. But for our purposes, let's keep both of these statements simple, okay? And again, I mean, if you show this to your physics major aunt or cousin or whatever, they'll take issue with my definitions, as rightly they should. But these are kind of great entryway definitions into what we're trying to study. Now, heat. Heat is the exchange of energy because of temperature difference. Okay, so if I had to distinguish between heat and temperature, because it's often in everyday language, we'll say, oh, that feels hot. That has a high temperature. And we want to be really clear on the difference. So temperature is a measure of whether an object will give up internal energy and we'll say it does if it's in contact with a lower temperature body temp and heat is a measure of energy exchanged between objects. Okay. So temperature is a measure of equilibrium. Heat is a measure of energy. Now, the refrigerator form of the second law of thermodynamics. I like saying it like this. By the way, I call it the refrigerator form. I want to be really clear. This is not something you're going to find in a textbook. It's just, once again, given that this is an accelerated physics class, I want to make absolutely sure we have definitions that make sense to us in what we're doing. And so this is actually part 2, so I'll tell you what. I'll take a look at this in the next video.